Hi everyone, my name's Andrew Martin. I'm a PhD student at Cardiff University in the UK. I'm on board the Joydes Resolution and I'm an alteration mineralogist. My job is to look at funky looking coloured things. 1.5 kilometres below us is the Brothers Caldera. So this is an underwater volcano. So originally we have nice black lavas erupted on the seafloor. What we've actually got happening is we've got very hot seawater derived and magma derived fluids flowing through these rocks underneath us at this very moment. And these things are very, very hot, so up to sort of 350 degrees. And as they flow through the rock, what they're doing is stripping out primary igneous minerals and metals, altering the primary minerals to secondary minerals, so things that have very, very different colours. So alteration is very, very important because if you think of it on a global scale, most of the altered rocks are where all our mineral resources are in the world. So around the world there are lots of different terrains, we call them ophiolites, and what these represent is fragments of uplifted oceanic crust. My PhD focuses on the Troodos ophiolite, which is on the island of Cyprus. It's a great place to study, very nice warm weather. So it's obviously not as difficult to study these ancient on-land analogues as it is to get to the bottom of the ocean. But unfortunately with the on-land analogues we really lack the understanding of the fluid chemistry and how that evolves over time, which is what we can do really well at Brothers. There are a wide range of metals that are spewed out of volcanoes. Copper, the fundamental thing we use in all electronics, so if you think of your Tesla, it's got a lot more copper in than your everyday car. Things like cobalt and lithium that you might be familiar with in your high-tech batteries. Tellurium and selenium, so these are things we use in photovoltaic solar cells. So obviously if we want to push for clean energy, it's really, really important to understand how metals move from magma to form ore deposits. I spend quite a few hours of my day looking at the microscope. It's quite interesting sometimes, especially if we have a large swell going on. The microscope kind of goes in and out of focus, which is always good fun, but it's such a great facility to have on board. It really helps us. One of the technicians, Seth, will basically cut this really, really thin. So thin that you can actually shine a light through it. All the different minerals have different optical properties, and from those properties and the shape of the mineral grains in this section, we can identify the different minerals. Being able to see them in such detail is absolutely fantastic. It's a world that people do not see, so you get some really, really fantastic, vivid colours. It's rocks like you've never seen rocks before. So this is my first research cruise. It's been a fantastic experience. How many people have been on a boat for 2 months, let alone on a boat drilling an active volcano? The science party in general has been absolutely fantastic. It's crazy to think that there are so many scientists from so many disciplines, from so many parts of the world, all putting together for one common goal. It's really, really exciting to think that we on board this boat are the first people to look at these samples. Minutes ago, these samples were at the bottom of the Pacific Ocean, and now they're up on our core table, we're describing them. So it's absolutely fascinating to think that that's one, possible, but two, to be part of the science that goes with that.